In the step called placement, the components of a chip are placed on its surface in such a way that no two components overlap. Many millions of components may have to be placed on a single chip. All the components are rectangular, but their sizes can vary a great deal. The large components are called macros. As these take the most space, they are placed first. We will deal with the placement of the macros in the second video. For now, we will assume that they have already been placed and will now look at how the many millions of small components, the so-called standard cells, are placed. The standard cells all have the same height, but they vary in width. That is why they are placed in rows on the chip surface. The components on a chip are interconnected by means of so-called nets. Later, in the step called routing, these nets will be implemented with wires, which must be as short as possible. Thus, components that are connected should be as close together as possible. If one allows overlapping, then it is very easy to find a placement that minimizes the total length of all nets. In order to find a good distribution of the components on the chip surface, one chooses a quadratic target function and can then formulate the problem as a so-called quadratic program involving a very large but sparse system of equations which can be solved in a few minutes, even for several million components. One now places a grid over the chip surface and uses the solution of the quadratic program to place the components within the fields of the grid so that all components have sufficient space. One then repeats this step many times using an increasingly finer grid until only very few components remain in any field of the grid. In the last step, the so-called legalization, all the components are placed without overlap along the rows. This is done while trying to move the components as little as possible from their given positions.